Determine the molecular formula for each of the following. The first problem, we have a compound that contains carbon and hydrogen, which has a molecular ion with an M by Z value of 72. So basically this 72, since it represents the molecular ion, this is going to be the mass of the compound, right? Now, to find the molecular formula of the compound, we can easily apply rule of 13, where we divide the 72 by 13. Now, why 13? Carbon's atomic mass is 12, and then hydrogen's is 1, and both to put together, it's going to be 13. So we are first going to find out how many carbons and hydrogens are present in this mass. So let's first divide it by 13. How many 13s are there in 72? There are totally 5 13s, right? So that corresponds to 65, and the remainder here is going to be 7. So this is the remainder, and this one right here is a quotient. Now we are going to take that, now this number right here, 5, is going to represent that there are 5 carbons and 5 hydrogens for sure. And then this remainder should be added onto hydrogen. So basically, this is going to give us the formula of C5H12. This is how you will be using rule of 13 to identify the molecular formula of the compound. Now let's see how we can apply this to a compound which has got heteroatoms. Okay, so here we have a compound that has got carbons, hydrogens, and also it has got 1 oxygen. Okay, and this has got a molecular ion with an M by Z value of 100. So this is going to be the mass of the compound. First, we are going to find out how many carbons and hydrogens are present in this compound. And then we are going to add an oxygen and then subtract the amount of carbons and hydrogens that corresponds to that 1 oxygen. Okay, so let's do the rule of 13. So we are going to divide this 100 by 13. How many 13s are there in 100? So 13 times 7 is going to be 91. So the quotient would be 7 and the remainder would be 9. So we can take that there are 7 carbons and 7 hydrogens, and we are going to add this 9, which is the remainder, to this hydrogens. Okay, so it's going to be total of 7, C7 and H16. Okay, so now we have found the formula in terms of carbons and hydrogens. And the next step that we are going to do is we are going to add 1 oxygen and subtract the mass that is equivalent for this 1 oxygen in terms of carbons and hydrogen. Now, what is the atomic mass of oxygen? This is going to be 16, right? Now, how many carbons and hydrogens are going to be present in this 16? You can only have 1 carbon, which is going to be equivalent to mass of 12. And then the remaining is going to be 4, which is going to be 16 minus 12, that's going to be 4. So you can take that in terms of hydrogen. The mass of 1 oxygen can be considered to be the equivalent of mass of 1 CH4, right? So we're going to add this oxygen in this molecular formula, and then we are going to subtract CH4. Okay, so that's going to be equivalent to 7 minus 1, it's going to be C6. 16 minus 4, that's going to be equivalent to 12. And then there is an oxygen that you're going to add. Okay, so this would be the molecular formula of the compound, which has got few carbons and hydrogens and 1 oxygen with the molecular ion peak existing with an M by Z value of 100.